Alright class, in this video we're going to solve a non-homogeneous differential equation with Laplace transforms. So once again we're going to take the Laplace transform of both sides, and we're going to use our table for that. And the Laplace transform for negative 8e to the minus t. Okay, so over here, Laplace transform for y double prime is s squared y. Remember, s's go down, derivatives go up. So this is minus 2s and then minus 12. Okay, and then minus 2 transform for y is sy minus 2 plus 5y. And that equals the Laplace transform for e to the minus t is 1 over s plus 1. So this is going to be negative 8 over s plus 1. Alright, now, so we move everything to the right-hand side, and then we factor out the y. And we know what we're going to get. We're going to get the characteristic equation, or polynomial. So that's going to be s squared minus 2s plus 5. Okay, on the other side we're going to have a positive 2s, and then we've got this minus 12, and we've got a plus 4 there. So that's negative 8 on the left, so it'll be positive 8 on the right. So this will be 2s plus 8 minus 8 over s plus 1. Now, before we can go any further, we're going to want that to have a common denominator. So we're going to multiply this term by s plus 1 over s plus 1. And when we do that and stick it all together, we're actually going to end up with 2s squared minus, plus 10s. The 8's are going to end up canceling. And that's going to be over s plus 1. Alright, and then we divide this term, and we get that y is going to equal 2s squared minus 10s over s plus 1 times s squared minus 2s plus 5. Alright, so once again we moved over to Laplace Happy Fun Land. We've got a rational function. We can split it up in terms of partial fractions. So this is going to be in terms of partial fractions. I'm going to have, let's see, I think I did this the other way in my notes here. So as plus b over s squared minus 2s plus 5, and then plus c over s plus 1. Okay, and then when we line up our numerators, let's see what happens. We're going to get 2s squared minus 10s. Oh, by the way, I should mention this. It's actually okay. Let me just divert for a second. It's okay if you want to make this equal to 2s plus 8 times s plus 1 minus 8. It actually works out pretty well if you want to just leave it like that. And I would say in the real complicated ones, that's what you want to do. You don't want to mess around with having a thing that, or multiplying a giant thing out and then having to plug numbers into it. This is going to be easy to plug numbers into as well. Okay, but since we went ahead and did it, we're going to use it. Okay, so this is going to be as plus b times s plus 1 plus c times s squared minus 2s plus 5. Okay, so the nicest value is negative 1. And that's going to give me 2 plus 10. Sorry, this is a plus. I keep copying it down wrong. This is going to give me 2 minus 10, so that's going to be negative 8. That term, the a and the b go away. And then negative 1 squared plus 2 plus 5, that's going to be 8c. So this one came out really nice. So c is negative 1. Okay, so s equals 0 would be the other somewhat semi-nice one. That's going to give me 0 on this side. Okay, that's going to give me 5c, and it's also going to give me 0 there, but b. Okay, and since c is negative 1, that's going to be negative 5, so b is 5. Okay? And then lastly, we can collect on s squareds. It's not too bad. Over here it's 2. Here we're going to have an a plus c. And once again, c is -1. So when I move it over here, I'm going to get that a equals 3. Alright, so let's rewrite this guy in terms of its decomposition that we just figured out. So we've got 3s minus 5 over s squared minus 2s plus 5 minus 1 over s plus 1. Okay, before we do the transform, we're going to have to complete the square on that. That's an unfactorable quadratic. So notice the completing the square, we would say this is s squared minus 2s plus 1 plus 5 minus 1, and that's how we would complete the square. And then we're going to have another step after that. So this is going to be 3s minus 5 over s minus 1 squared plus 4 plus minus 1 over s plus 1. And then one other thing, remember that s has to match this s minus 1. So I need to change that into an s minus 1. So that's 3s minus 1. Okay, so what did I really do? I put in -3, so I have to add 3. So I've already got a 5 there, and that's supposed to be a plus. I keep getting my signs wrong. Okay, so when I add my 3 in, that's going to turn into 8. S plus 1. Okay, so this is the last step, and then I can separate those. So what's going to happen here? The s minus 1s are going to turn into an e to the t, and then I'm really looking at 3s plus 8 over s squared plus 4. I want to think of 8 as 4 times 2, because the s term is going to give me cosine, the constant term is going to give me sine, but since this is a 4, I want to see a 2 up there. Okay, so the Laplace transform for capital Y, which is equal to my solution, y of t, that's going to be, so 3s over s squared plus 4 is cosine, and I've also got an e to the t term. So that's 3 e to the 2t cosine 2t. And then 4 times 2 over s squared plus 4 is going to be 4 e to the t sine 2t. And then the last term, we're going to have minus e to the minus t. And there, well, I should circle that part too. There is your solution to the differential equation.